Alright guys, welcome to lesson 5 where we're going to talk about mixing data types, casting, and constants. So before we've had ints and doubles and they've been separate. So today what we're going to do is we're going to start learning ways to kind of get them together to make our programming lives a little bit easier. So go ahead and get your program set up and we're going to come in here and do double sand equals 78.2. Okay, and remember before when we set other variables equal to each other, so we're going to do int trap equals sand, which we get an error for. So if you hover over the error, it says type mismatch, cannot convert from double to int, because we have int saving as a double. So what we need to do is we're going to cast this double as an integer. So even this 0.2 here, Java is going to have a little tantrum about because it wants to not lose data ever. So what we'll do is we'll cast it. So in front of sand, which is our double, we're going to force it to be an integer. So in parentheses, in front of sand, just write int in there. And then we're going to come down and we're going to print. So if we run it, it prints 78. So it forced our double to be an integer. But I want to show you something. So if you come back up to line 11 and change that 78.2 to 78.9 and we run it again, it's only going to give you 78. So all casting does is it cuts off everything after the decimal point. Now if it were the other way around, we said like int tater is and double dot equals tater, it's not going to give us an error because we're not losing any information. So if we go to print that, it'll print just fine. I'm going to print dot. All it's going to do is add a decimal point because it's printing a double. So you only need to cast if you're going to lose information. So that's one of the things that we really want to point out is that you only need to cast if you're going to be losing any kind of information. So you can also put in mixed data types. So what do we mean by mixed data types? That's basically where we're saying that you're using a double and an int in the same thing. So if we have double corn equals 4, which we can do, it's just going to make it a decimal, and cob equals 3, we can interact with them, as long as we have them set as a double. So let's go ahead and print that. So I'm going to print divide, I'm going to run that. And there's an error. Let's look and see. I forgot a close parenthesis. So go ahead and run it. Okay, and it prints 1.33333, which is exactly what we'd expect to see. Now you may have noticed, so I'm going to come down a couple more lines. If you do like system.out.println and you print 5 divided by 4, it's not going to give you what you expect. It's going to give you 1. So whenever you are dividing this way, it's going to round, it's not going to round, it's going to give you the integer that it is without the remainder. So if we did like 5 divided by 6, which you would think would round up to 1, it's going to give you 0. So what I want you to look at is we're going to play a little bit with casting here. So if you come in and you see double dare is equal to 5 over 4, and we system out print dare. Let's make that system out print line. I'm going to copy and paste this because we're going to do 2 different ones. They're going to be similar, so I'm going to call this dare2, and we're going to print dare2 here. And if you run it, it's going to give you 1.0 because it's a double. But even though it's a double, it does integer calculation on your dividing. So let's play with some casting since we know it does integer division. So I'm going to come in line 26 and I'm going to put double in front of 5/4. And in line 29, I'm going to put double. Then I'm going to put 5/4 also in parentheses. So let's run it and figure out what happens. So we have 1.25. And this one gives us just 1.0. So in Java, whenever you're dividing, any whole number division does integer division, meaning it's going to give you the whole number without rounding. So like 3/4 would be 0 because that's the whole number. And 8 divided by 3 would be 2. But if you put one of them as like 3.0, it would give you that decimal. So casting works the same way. So like in that example that we just did, what happens is we cast that first number as a decimal, which is why it resulted in a decimal answer. Whereas the second example, we did 8 divided by 3 in parentheses. So what happens is it does this integer division within these parentheses, so it gets back that answer 2. Then it makes it a double, and so it prints 2.0. Okay, so I know that's probably a little confusing, but the more you play with it, the more you will start to see it, trust me. So the last thing that we're going to talk about in this one is constants. So in math class, you guys have constants, which are numbers that never change. So an example of that would be like double, we'll use the variable pi, which is 3.14159. It's more, but leave it that way. So the thing is with pi is that we don't want it to change. Pi is pi. You can't make pi different than pi because that's ridiculous. So if you want something to stay the same forever for your whole program, write final in front of it. Final tells us that we can't change anything about pi. So what this means is that if you try to do pi plus plus, it's not going to do it. It's going to give you an error. It's going to say, cannot make that happen because it's a final. See, it's blank. It's not using anything. It's final. You can't fix it. You can't do pi equals pi plus 1. It's not going to let you do it. It's a final. It's a constant. It will never change. You may notice that we made pi capitalized. So one of the conventions for using a final is that it's all caps. That is it for lesson 5. So for lesson 5, you have some questions on Moodle, and in your book, you have a project called Mixed Results. It is on page 28 of your book. Let me know if you have any questions, and good luck.